Welcome and thanks for watching this video. I want to give a short introduction about the text table tool. The text table tool is designed to analyze and modify a fixed column length plain text file. To do so, it implements two domain-specific languages, one to describe the file structure and the other language is to operate on the file content. I want to say a few words about the motivation to write this tool because someone might ask, why do we need it? For existing files there are existing tools, and for new developments you should try to avoid this kind of interface. These are very valid points, I agree on that, but I could see plain text files in many occasions in practice and the existing tools are not as convenient as they could be. First of all, we must state plain text files are still frequently used in practice. You find them especially with legacy systems. They are also used many times to do prototyping when people hesitate to set up a full-flavored, up-to-date data exchange infrastructure, because it's true that technology in this area evolved, but it also became more difficult and hence more expensive. The second point is, as we have seen, there are still good reasons to use plain files for data exchange, and one point must be emphasized: XML isn't always the best choice, especially when we have many rows and many columns. Then we get a very bad ratio between the structure information and the payload transported with XML. So far the reason for plain files. I want to say I don't want to advocate for plain files. I'm far away from doing so. I just want to point plain files are still in use and they will be used in information technology. The other point is why we need a tool for that and why we need a new one. I've seen many people getting really upset working with plain files. Many times they had to perform very simple tasks, or better to say the task would have been very simple if the data had been available as a table, but as we know it isn't. It's just a sequence of characters in a text file and nothing else, so working with plain files is really tedious and error prone. So root of the matter is the definition of the file structure. I think there are other tools which can support that, but they often use a GUI to give the structure definition, and I think here we're better off with a domain-specific language, and I will put more light on that point with the next slide. I want to discuss now the advantages and disadvantages of some approaches to define the structure description of fixed length plain files. The most popular approach is to provide a GUI to give the structure description. A GUI can be understood very fast by users. However, handling can become very clumsy. If you have many columns in your specification, clicking and choosing from all the combo boxes is very tedious. Think of an interface with more than 30 columns. You can spend a lot of time just with defining the interface. Many GUIs also don't support to copy and paste definitions, so there's no quick way to transfer from a specification to the definition in the GUI. But the biggest disadvantage is many GUI-based tools don't support to import and export the definition itself. Hence there's no possibility to exchange existing import definitions with other people. Exchanging is really simple if you have a file describing the structure with an XML approach, so that's quite better. But I dislike XML when users have to read the file very frequently. Although XML is human readable, that doesn't mean that humans like to read XML. It's still very technical and not really user friendly. But as file, you could easily exchange the definition either as email attachment or email content. The text table tool uses a domain-specific language. I think that combines the advantages of GUI and the file approach. It could be understood very easily and also handled as a simple text file. You have to introduce the description with the keyword plain, followed by an ID of the interface or describing the interface, and between begin and end you can list all the columns you have in your interface files, saying from which character position to which character position a single column spans. Okay, with the last slide I want to talk about the basic concept of the tool. It's pretty simple. You give a text file as input, and then you apply the structure description and transform the data utilizing this structure description to the table data. On the table data, you can perform your operations, doing your analysis, and once you're finished, you can again apply the structure description the other way around and generate the output text file from the existing or modified table data. But now I think it's enough with watching slides. Let's have a look at the tool. So here we can see the tool itself. The tool has three main areas. In the first area you can place your text file content. In the second area you can define the structure description, and in the third area we can see the content from the text file as table data once we have applied the structure description. So now let's give a very simple example. We define a very simple text file. Let's say we have one column with spanning over 3 characters and another one spanning 4 characters. I populate the file, then I go into the description tab, and when we have to introduce the file description with the keyword plain, give an ID, test here for example, then we must start with the keyword begin and say we have column 1 with the length 3 and column 2 with the length 4, and then we can close the definition with an semicolon. Once we have defined the structure, we can go into the table tab and say processing from text to table. And what we can see here is the content of the text file as table data applying this definition. That's pretty simple. Maybe let's have a look at the last slide. So what we did is we applied the input here as text file, then we gave the structure description here and used the structure description and the text to get the table data. That's what we did with processing from text to table. Then we got the table data, and now we can look at the data and maybe do also some changes. We want to see the first 2 lines of column 1 should have CCC instead of AAA. And after that, according to the slide, we must be able to re-render the table data using the same structure description to the text file. Let's try this. Go back to the text file, say processing from table to text, and then we see that also the content in the file had changed. So this is the basic concept of the tool for a very simple example. Now we are ready to start with a more sophisticated example. I have prepared some sample data here containing customer data. I have also a file specification that could be also found in practice. We have the column name. We have two columns saying from which character position to which character position the column spans. And yes, we have the tool. So what I have to do at first is I copy the content of the file to the tool. So here an open dialog is missing for the tool. That will come with one of the next version, of course. And then we have to go into the text table description and we have to describe the structure of our sample file. To do that, go to the file specification and we can make our life very easy here. We use an Excel formula where we give the syntax column name from to, as we have seen that in the slide. We'll go back to the slide for this. Here we have this style of syntax. There's also another one, that's the one we tried with the first example. You can either say from position to position, or you can say column ID length. Two alternative syntax, both is possible with the tool. But back to the file specification, we will choose the from to syntax style, and then we have to give the column ID saying from position to position, and then we have generated the syntax for the syntax fragment for a single column. All we have to do is to fill at the end of the specification, and then we can copy and paste the syntax fragments to the tool. Here we are. That's perfect. Maybe let's change the ID, say customer data. Right now that's not important. You can choose any ID you want here. Then go to the table tab, and then we can say again processing from text to table, and then we can see that we have the content of the text file now here in a table, in a data table available. Now we transformed the content coming from the text file to a table style here. Once we have done so, we want to perform selects on the table. We want to modify the data, and we can do so with this simple text area. Here we can enter some SQL-like statements to perform all these tasks on the table. I want to start with the select statement, where we are able to select single columns or a subset of columns. To perform a select, we have to enter the keyword select. So that's quite close to what you know from databases. Say star to select all the columns, and then you might expect a from clause, but this is one of the differences between the query language style in the text table tool and the SQL language from databases. Since we have only one table here, it makes no sense to say from which table we want to select. So we can skip the from clause completely and continue directly with the where clause. And then we want to select a single customer. We have a customer number, and we want to check if is this customer present in the text file. We can say custom, so that's just the column ID of in the column ID of the structure description, cust number equals, and then we apply the customer number. So that's important to know. For the tool, everything is a string. The tool isn't aware of any data type. It doesn't know anything about date, timestamp, decimals, or whatever. Everything is a string. So if we want to use a literal value, we always have to apply it in double quotes. To execute the statement, we have to go to processing, say execute query language, or there's also a shortcut key, or you can also press the according button in the toolbar. And then we get the specific customer. To make the select statement a little bit more sophisticated, we can use here AND or conjunctions. So maybe we want to select this customer with this specific number and all the customer having their email account at Gmail. We can apply another Boolean expression here and say or email matches. So this is the other comparison operator available for the tool. It's either equals or matches, and then we can say dot star. Matches applies a regular expression. That's important to know. It's just a regular expression as you know it from the Java string class. It does nothing else but delegating the regular expression string to the Java string classes. So say matches dot star gmail.com, and again execute it, and then we got the specific customer with this customer number. It's here, so that's the only one with another host name in the email address than Gmail. All other customers have their email account at Gmail. So once we have selected the data, we maybe want to modify the data because we have seen there are flaws in the data, some inconsistencies. We need to fix them manually. To go back to the source result, we have to say select star, pressing F5. One note here that's important to know: if you want to apply changes manually directly in the table, you have to do that always on the source table, because you don't see the difference in the tool between the source table and a select result. A select result, as long as it is not select star, always returns a new result, a new table, and not the source table. And you can modify only the source table if you want to utilize from table to text. So the table here in from table to text is always the source table, not the select result. That's important to know. Okay, we have applied a select star, so we see again the source table. That's perfect. And maybe we know that all the customers with their email account at gmail.com comes from system AAA instead of PRD, and we want to change that. To do so, we can use the update statement as we used to use it on SQL databases. Update set. So again, we don't have to apply a table. So normally it would be update table set, and then we can give the column list we want to change. The first column we need to change is system, say equals AAA instead of PRD. But we also need to change logsys, because what we can see here, that logsys is only the concatenation of system and client, and this is what we want to do in the update statement also. Then we have to provide comma and give another column, that's logsys here. Say logsys equals system concatenated with client. So concatenation is also similar to what you know from a database. And then we can give the where clause, where email matches dot star gmail.com, and then we can press F5. And then we see that all the customers with their email account at Gmail have now system AAA, and the logsys also changed. Perfect. Maybe what we also can see here, that the email is not properly formatted. We have lower and uppercase characters. We want to have everything in lowercase here. We can use one of the built-in functions. There will be another video. I will talk only about the built-in functions and all the possibilities coming with the with the query language here. But now let's pick just a simple example where we can use a single built-in function that's lowercase. So let's say update email equals lowercase email. Then we get all the emails in lowercase, pressing F5, and we see, yeah, perfect, that's what we have expected. And now a very interesting question. Now we want to re-render the changed result to the text file. And that's of course pretty easy. All we have to do is say processing from table to text. And as we can see, wow. Also, the text file has changed and we have applied all the changes that we did on the table also in the text file. Now let's talk about the last type of statement possible with the query language. That's the delete statement. We can of course also delete single rows from the data table. To do so, we need to use the delete statement. That's also very similar to what you know from databases. Say delete where, and then we want to delete all rows with a system where the system is not AAA. So in other words, we want to delete all rows where the data doesn't come from system AAA. So the where clause to do so is where system equals PRD, and then perform the statement, and then we see that we only have here data coming from system AAA, or in other words, we only have customers with the email account at gmail.com. And of course, again, we can say processing from table to text, and then we only have this kind of rows in the text file. So that's enough for the first video. You got a short introduction into the tool. I want to really say thank you for watching, spending your time watching this video. And I would really appreciate if you also take the time to watch the other videos where I will talk in detail about the syntax of the table description and the possibilities of the query language. Again, thank you very much for watching.